Welcome to an introduction on gases. First of all, we have to consider what gases are and then consider some of the characteristics of gases. One of the first things that we have to do is gases are made of atoms or molecules. Oxygen is O2, hydrogen H2, carbon dioxide, nitrogen, which is N2. These are basically particles that are flying around inside a container. Could be the classroom, could be a beaker, could be a lot of different places. These particles, because of their speed and their size, actually have what's called kinetic energy. And kinetic energy is always a measure of 1/2 the mass times the velocity at which they're traveling. Now, what we see as temperature is actually is the average kinetic energy of the molecules. So on average, all the gases that are in the room, if it's 70 degrees, they're all traveling, they all have roughly the same kinetic energy. The other thing that we have to consider about gases is we have to consider pressure. And on the next slide, we're going to talk about what pressure actually is. We also have to consider the container that they're held in. And so as we go forward and we start talking about pressure, to give you a little idea of what pressure actually is. Okay, pressure, if you look at this weight is known as a force, basically pushing down on an object. And pressure is actually a measure of force per unit area. So this particular mass, whatever it might be, some sort of cylinder, is weighing down on top of this certain area. If we have the same weight pressing down on a smaller area, that means we have more pressure. If we have a larger area pushing down on a large area, then we have less pressure. So some of the girls in the class can actually exert more pressure than I do, just simply being on high heels. They're exerting the pressure on a smaller surface area. So if we look at force is a measure of what's called newtons. And newtons per, notice it says force per unit area. Well, that would be force per meter squared, which we also know as what's called a Pascal, okay, a PA. Now, a lot of times a Pascal isn't very large, and so what we tend to do is we tend to measure things in kilopascals, which is 1,000 pascals. So that is 1 kPa. Now, if you look at the pressure of gases, and if you look down at this helium balloon, we have all these little gases that are flying around, and they're colliding with the surface of some object. So in the case of this balloon, the pressure inside the balloon is actually equal to the pressure outside the balloon. In other words, the number of collisions with the little surface area is equivalent both directions. And that's why the balloon stays inflated. If the pressure outside was higher, the balloon would collapse. If the pressure was higher inside, the balloon would actually expand. So as we start to look at this, what we're doing is, let's assume we're at sea level. And one of the calculations that we have is that on average, the amount of gases inside or outside at what we call atmospheric pressure, the pressure at sea level, is actually equal to 101.2 kilopascals. Or we could say it's equal to 101,000 newtons per meter squared. Now, this is a measure of pressure that is commonly used in physics because we're dealing with newtons. What happened before we started using this kilopascals is we started looking at something called millimeters of mercury. And the guy who kind of figured this out was a guy by the name of Torricelli. And what Torricelli did is he made a barometer. And this barometer, what he figured out is that if he took a column full of mercury, and I'll expand this a little bit so you can see what I'm talking about. Make it big. If he took a column full of mercury and he talked his brother-in-law into doing some work, he would actually take this column of mercury, fill it completely full of mercury, flip it over into a tub of mercury, and it would actually draw off the top. And what I mean by that is it would pull down from the top of the tube down a little bit, like that. This space up in the top of the barometer would actually have nothing in it. It's a vacuum. There's no gases, nothing up in here. What he found out was the distance from the top of the mercury at the bottom here and the very top of the column on a normal day, that distance, right? Ooh, that's an ugly distance, but that distance right there stood up 760 millimeters tall. So at sea level, he figured out that, you know what, on an average day, mercury stands at 760 millimeters tall. Now, a second ago, I told you guys this number 101.2 kilopascals. So here's the deal. On an average day, the pressure is 101.2 kilopascals. So what we have here is we have these two equivalents. We actually have 760 millimeters of mercury is equal to 101.2 kilopascals. Okay? And so those two comparisons are actually telling us if we have 760 millimeters of mercury, then we also have 101 kilopascals. Now, we live in Kalispell, Montana. We're at 3,500 feet. We are never at 760 millimeters of mercury. We're always like at 690 millimeters of mercury. Our pressure is significantly less. So we typically live at 690 millimeters of mercury. Now, here's the deal. If we need to calculate kilopascals, we simply use what we've done in a lot of our other problems this year. We use a little dimensional analysis. We set up the dimensional analysis. I want to get rid of millimeters of mercury. I want to get to kPAs. So we know the relationship or the ratio is 101.2 to 760. Now, from that, we should be able to calculate. Take your 690 times 101.2 divided by 760, and that will give you your pressure in kilopascals. Now, there are a variety of pressure units. And so one of the things that we're going to look at is some of the pressure units we deal with. Now, we figured out that 101 kilopascals, 101.2 kilopascals, is equal to 760 millimeters of mercury. Now, to give Torricelli credit for the work that he did, we call 760 millimeters of mercury, we actually call that a torr, standing for Torricelli. And so what we have is 760 millimeters of mercury equals 760 torr. Now in chemistry, we also work with one other unit on most of the time, and this is called atmospheres. And we say that at sea level on a standard day, then the pressure is 1 atmosphere. Any other pressure in atmosphere, if I say it's 0.9 atmospheres, well, that simply means that we're about 90% of the atmospheric pressure that you are at sea level. So if I said it was 0.90 atmospheres, then what I would want to be able to do is calculate something like, well, how many millimeters of mercury? So I would set that up just like we always do. Atmospheres, get rid of atmospheres, go to millimeters of mercury, and simply say, well, 1 atmosphere equals 760 millimeters of mercury. Take our 0.9 times 760 and get our calculation in millimeters of mercury. So converting back and forth between atmospheres, kilopascals, and torr is important in this unit. What we're going to do is do some calculations of pressure. Once we've done the calculations of pressure, then we'll move on to some other concepts of volume and some of the gas laws that are out there. So this is gas laws video 1.